When it comes to square roots and radicals, there are a few things you simply need to memorize, and there are about 5 core concepts you need to understand. The first thing to memorize is a list of perfect squares. You should know the square root of 4 is equal to 2, the square root of 9 is equal to 3, and so on. You should know this list all the way up to the square root of 256 is equal to 16. It's also helpful to know the square root of 400 is 20. Additionally, it's helpful to know that the square root of 2, while not a perfect square, is 1.4. The square root of 3, likewise, is not a perfect square, but it is 1.7. The square root of 5, it's helpful to know, is 2.23. The first broader concept you need to know is that the square root of x times y, that is the same thing as the square root of x times the square root of y. This rule becomes helpful when you're trying to simplify radicals that are not about perfect squares. For example, I have no idea what the square root of 24 is, but I could rewrite that as the square root of 4 times 6, which is the same thing as the square root of 4 times the square root of 6, which is the same thing as 2 times the square root of 6. There's a good possibility that 2 square root of 6 would be your final answer, but if not, I could further break that down to be 2 times the square root of 3 times the square root of 2. And then I could write that as 2 times 1.7 times 1.4. While it may not be pretty, it would be enough to help me estimate my final answer. The next concept has to do with dividing radicals. You should be aware that the square root of x over y, that's the same thing as the square root of x over the square root of y. So if a problem had an expression like the square root of 4 over 36, you could break that down to be the square root of 4 over the square root of 36. Then you could write that as 2 over 6, which then becomes 1/3. If you try to simplify this fraction, you may find out there's not a whole lot you can really do. And that's because 2 and 5, they're both prime numbers, so we can't factor anything out. And they're not perfect squares, so there's nothing we can do to make the radicals go away. In fact, in some exams, this final answer might be good enough. But you should be aware of a rule that's more about what's proper than a steadfast rule. And that is, you really shouldn't have a square root in the bottom of your fraction. To make that go away, what you can do is you can multiply both the top and the bottom by the radical in the denominator. So in this case, I'm going to multiply both top and bottom by the square root of 5. Since I'm multiplying both the top and the bottom of the fraction by the same number, I'm really not changing the value of the expression, just the way it looks. So then the top becomes 4 times the square root of 10, and the bottom becomes 3 times the square root of 25. And since 25 is a perfect square, I could rewrite the bottom as 3 times 5. So my final fraction is 4 root 10 over 15. If you have a problem where you have both a radical in the denominator as well as a addition or subtraction sign, you have to find a special way to get rid of your radical. You have to take advantage of something we learned back with quadratics known as the difference of two squares. You should remember that a squared minus b squared, that factors out to be a plus b times a minus b. And we can use that to get rid of the radical in this. A plus b and a minus b are called conjugates of one another. When you have a radical with an addition or subtraction sign in the bottom of a fraction, you get rid of the radical by multiplying both the top and the bottom by the conjugate of the denominator. So in this case, I'm going to multiply both top and bottom by 5 minus the square root of 2. When I multiply the top, I can just wrap parentheses around my 5 minus root 2, and then multiply and distribute my root 5 both onto the 5 and the negative root 2. So the top of my fraction becomes 5 square root of 5 minus the square root of 10. When I multiply the bottom part of my fractions, I'm going to wrap parentheses around the 5 plus root 2 and around the 5 minus root 2. When I multiply, I see I'll be following the same pattern of a plus b times a minus b, and I should know that that's going to equal a squared minus b squared. So I should know the bottom of my fraction will become 5 squared minus the square root of 2 squared, or 25 minus the square root of 4, or 25 minus 2. So the bottom of my fraction really ends up being 23. And my final fraction then is 5 root 5 minus 10 over 23. And you can see I no longer have a radical in the bottom of my fraction. Adding and subtracting radicals is pretty simple. You pretty much use the same methods you would for adding and subtracting variables. For example, if I had the statement negative 3x plus 2x, I would simply combine my negative 3 and positive 2, and that would give me negative 1x. And that's exactly what I'm going to do with these radicals. I combine my negative 3 and my positive 2, they become negative 1, and then I just drop down my root 5. That doesn't change. It can be a little more complicated if it appears your radicals don't match. In this case, your first step is to simplify the radicals as much as possible. So I can look at the square root of 12. I could rewrite that as the square root of 4 times 3, which is the same thing as the square root of 4 times the square root of 3, which is the same thing as 2 root 3. On my root 20, I could do something similar. I could rewrite that as the square root of 4 times the square root of 5, which is the same thing as root 4 times root 5, which is the same thing as 2 root 5. Now I can rewrite the equation as negative 3 times root 12, which I discovered was 2 times the square root of 3, plus 3 root 3, nothing I can do there, plus 3 times the square root of 20, which became 2 root 5, or negative 6 root 3 plus 3 root 3 plus 6 root 5. Because my first two terms are both attached to a root 3, I can combine the coefficients. So I add a negative 6 with a positive 3, and I get a negative 3. Then I just drop down my square root of 3. With the 6 root 5, there's nothing else I can combine that with, so my final answer will simply be negative root 3 plus 6 times the square root of 5. And that's about as far as I can go.